Chapter 1: Magnetic Tales. Imagine walking into a library that holds the mysteries and wisdom of ages long gone. Instead of books on shelves, picture a space filled with invisible streams of energy, each with its own story about life on Earth from thousands, maybe even millions of years ago. This library isn't a place we can visit physically, but some scientists suggest that the Earth's magnetic field might just be a keeper of such hidden histories. It all starts with understanding what the Earth's magnetic field really is. Our planet is like a giant magnet with its poles, and it produces an invisible shield around itself. This magnetic field shields us from the sun's solar wind, protecting everything that lives on Earth. But could it be doing more than just protection? Could it somehow hold echoes of past civilizations? To explore this idea, we need to look at how magnetic fields can preserve information. This concept isn't entirely new. In the modern era, we use magnetic storage all the time. Think of hard drives or credit cards. These devices use magnetic patterns to store our photos, music, and data. Scientists use a similar process to read the history embedded in rocks and minerals through a field called paleomagnetism. When volcanic rocks cool or sediments settle, they capture and freeze the direction and strength of the Earth's magnetic field at that time. This snapshot allows geologists to understand pole reversals and the movement of tectonic plates. But what about human history? Ancient civilizations, like the ancient Greeks and Chinese, were first to document the properties of magnets. They didn't know what a magnetic field was, but they saw how lodestone and magnetite could point north when allowed to float freely. This led to the development of compasses, changing navigation forever and allowing cultures to connect across oceans. Even more fascinating is the idea that human-made items, perhaps from lost civilizations, might contain magnetic traces of their own. This concept propels a modern scientific journey to see if other stories are hidden in our planet's invisible field. Some researchers have theorized that certain materials used in old structures might have recorded information about the magnetic field strength and direction during the time they were built. These subtle clues can tell us something about what our ancestors faced and how the Earth's magnetic field might have influenced their lives. For instance, changes in the magnetic field could have altered the Earth's climate, which might have pushed ancient societies to adapt, migrate, or even collapse. One surprising discovery has to do with ancient pottery. As pots and bricks were fired, the minerals inside them cooled and locked in the magnetic field's signature of that moment. By studying these magnetic signatures, scientists can piece together timelines of past magnetic field changes. Such studies offer glimpses into the conditions that shaped human societies throughout history. In recent times, some fascinating studies have taken advantage of magnetic field records found in ancient hearths, kilns, and even the floors of long-abandoned settlements. Archaeomagnetism, a field devoted to piecing together past magnetic conditions from archaeological artifacts, helps paint a picture of how our planet's magnetic behavior might have influenced geomagnetic storms and even auras in regions that could have inspired myths and legends. Napoleon's Egyptian campaign, for instance, inspires curiosity about whether the Great Pyramid's construction aligns with specific magnetic events. Scientists wonder if the positioning of immense structures like it has any correlation with the magnetic characteristics of their time. The idea is not far-fetched, considering how some ancient cultures aligned buildings with astronomical bodies. Could magnetism have guided their hands as well? Therefore, the regular shifts and flips in the Earth's magnetic field, sometimes leading to periods of weakening and reversing, make one wonder about the influence of these changes on living organisms, including humans. Changes in the magnetic field can impact animal navigation. Consider migrating birds, sea turtles, and even some bacteria that rely on the magnetic field. Could ancient humans have intuitively sensed these changes as well? Wondering about the future, scientists ask if there is a better way to uncover information stored in Earth's magnetic memory. New technologies might one day let us read much more than the basic direction and intensity of the field. Instead of just telling us about past geomagnetic conditions, they may reveal complex interactions between life on Earth and the magnetic sphere surrounding it. For now, this emerging area of study offers enough thrill. It fuels our curiosity about what else might be hidden in plain sight, etched invisibly into the dome of energy protecting our globe. As research advances, we hope to understand not only how ancient civilizations lived in harmony with the Earth's dynamic magnetic field, but also how these invisible forces continue to shape our world today. Could understanding these fields lead us to anticipate future shifts, guiding us in unpredictable climate patterns or even future civilizations? Each discovery is like unearthing a new page in a never-ending story, one told not by words but by the silent dance of the Earth's magnetic whispers. It reminds us that our planet, even at its core, is alive and telling tales, inviting each of us to listen closely to the hum of history. Chapter 2: Field of Secrets. Imagine standing in a vast and open landscape, one that looks much like any other field you've ever seen. The wind rustles the tall grass, the sun warms your skin, and birds dart playfully in the sky above. But there's something peculiar and extraordinary about this place. Beneath your feet lies an invisible force that has flowed through our planet for millions of years, touching every corner of the Earth. It's the magnetic field, an unseen but vital guardian of life on Earth, quietly saving us from cosmic radiation and solar winds. Scientists have long studied this force to understand its behavior and its effects on life. But what if it could do more? What if, hidden within the shifting waves and currents of this field, lay traces and echoes of times long past? The Earth's magnetic field is a marvel of planetary science. It originates deep within the core, where molten iron moves and flows with such complexity that it creates a powerful and dynamic magnetic force. This protective shield extends out into space, forming a bubble-like structure known as the magnetosphere. Our magnetic field is not a static entity. It shifts, flips, and dances in patterns that scientists are still trying to fully map out. The poles have even reversed several times over the planet's history, a phenomenon known as geomagnetic reversal. These flips are irregular but happen on average every few 100,000 years. What's fascinating is how the field bears witness to the ever-changing nature of Earth itself. Now, let's delve into an intriguing idea posed by researchers and historians alike. Could the magnetic field hold clues to Earth's ancient past, much like a vast cosmic memory bank? While this thought sounds like it leans into the realm of science fiction, it invites us to explore what is already proven by science and to question how much more there could be yet to understand. Consider this: the fossilized magnetic records embedded in rocks, known as paleomagnetism. This is a fundamental field of geology, where scientists study the orientation of the magnetic minerals locked within rocks. When these minerals form, they align themselves with the magnetic field of the Earth at that time, almost like a compass frozen in stone. By examining these, scientists have pieced together the historical movements of continents and reconstructed past configurations of tectonic plates. This is one of the ways paleomagnetism tells the story of Earth's grand geological odyssey. In a similar vein, there's ongoing research into how ancient civilizations might have been influenced by the magnetic forces surrounding them. Imagine early navigators steering their ships by celestial cues, but with an innate understanding, passed down through generations, of the Earth's magnetic ley lines. Researchers have discovered ancient artifacts with magnetic properties, prompting questions about whether these societies had a rudimentary understanding of magnetism, and whether it impacted their navigation, construction, or rituals. As modern science pushes boundaries, new techniques in archaeology and geology continuously reveal surprising insights. For instance, certain archaeological find spots suggest past use of magnetized stones, not merely for decorative purposes, but as part of ceremonial sites. It raises the question, were our ancestors more attuned to the magnetic dance of Earth than we credit them for? Recent advancements in technology have also allowed scientists to model the geomagnetic field with greater precision. With satellites orbiting high above, scientists gather data that offer a snapshot of how charges flow and how the field alters over time. These observations have unveiled minor fluctuations and anomalies in specific regions, sometimes referred to as magnetic hotspots. Such areas can offer countless opportunities for researchers to explore localized effects of magnetism on the environment, potentially linking to historical weather patterns, animal migration, and even human activity. In our pursuit to understand magnetism's role in shaping earlier civilizations, we must also explore its potential to impact ours. While it's a protector, the Earth's magnetic field is not immune to change. Presently, there are shifts in the field that have caused some scientists to ponder potential impact on modern society. Magnetic navigational systems, power grids, and communication networks. Our reliance on them prompts crucial research into safeguarding them against magnetic fluctuations. Another captivating venture is examining the magnetism of ancient pottery. This field of study, archaeomagnetism, dates ceramics to chronological timelines based on their magnetic signatures. When pottery is fired, the minerals inside can record the direction and strength of the Earth's magnetic field at that moment. By comparing these records with known historical shifts in the magnetic field, archaeologists can date objects more accurately than ever before, enriching our understanding of human history. This ongoing story of exploration is a testament to human curiosity. As we continue to peel back the layers of time through the study of the magnetic field, we seek answers not only to scientific questions, but to deeper philosophical ones. How has the world around us etched its story into the unseen world? How have forces invisible to the human eye shaped the course of our history? As technology and science advance, we anticipate more revelations, each bringing us closer to a profound understanding of our place within the dynamic system of Earth. So next time you find yourself standing on a quiet field, give a moment to ponder the hidden mysteries lurking just beneath the grass. Imagine the Earth's ancient storylines, weaving a tapestry of secrets just waiting to be unveiled. The magnetic thread running through our planet might hold the key, unlocking countless pasts wrapped in the silent watch of time. Chapter 3: Earth's Memory Palace. Imagine walking into a room where every wall, every object, whispers stories of the past. What if the Earth could do the same? The concept that Earth's magnetic field might carry echoes of bygone civilizations is a captivating lens through which to explore our planet's history. To begin, we need to delve into what Earth's magnetic field really is and how it works. The Earth acts like a giant magnet. Deep within our planet, beneath the crust, lies a swirling ocean of molten iron in the outer core. This movement generates electric currents, which in turn create magnetic fields. These processes combine to produce a large magnetic field that extends far beyond the planet, shielding us from the harmful cosmic rays of space. Science tells us that this magnetic field has flipped many times throughout Earth's history. Known as geomagnetic reversals, these flips have happened over millions of years. The magnetic poles switch places, the north becomes south, and vice versa. The last such reversal happened roughly 780,000 years ago, and though we may not feel it in our everyday life, these changes are well documented in geological records. What is fascinating is how rocks can act as ancient diaries. When molten lava cools down and solidifies, the tiny iron particles within align themselves with Earth's magnetic field, like microscopic compass needles. These particles are then locked in place, preserving a snapshot of the Earth's magnetism at that moment in time. By studying rocks of different ages, scientists have pieced together a timeline of magnetic reversals and shifts, revealing stories about changes in Earth's magnetic field through ages. Our intense curiosity leads us to wonder if such a magnetic imprint could carry more than just records of polarity and intensity. Could it potentially preserve memories of what life looked like when these stones formed? This is where the imagination starts to gallop alongside the careful treads of science. While today's technology primarily allows the magnetic field to inform us of past geological and astronomical events, scientists are continuously exploring how much more there is to uncover. The idea that Earth's magnetic field might hold memory traces, in a way similar to how data is stored on a computer's hard drive, is still in the realm of theory. However, hypotheses in physics and data storage suggest it's worth investigating further. The scientific community has been exploring different aspects of this notion. For instance, scientists working in the field of archaeomagnetism study ancient artifacts like clay pots, bricks, or baked earth to understand the magnetic conditions of the past. When these objects were heated, their magnetic particles realigned with the magnetic field of that time, offering hints of both human activity and the magnetic environment. These records can provide indirect insights into how civilizations lived and adapted to the changes around them. Furthermore, there are interesting theories in the realm of biomagnetism that contemplate how living organisms might have interacted with magnetic fields. Some birds and other animals possess an ability known as magnetoreception, the capability to sense magnetic fields. This sense guides them in migration and navigation, hinting at a natural connection between biology and magnetism. If ancient people had any comparable capabilities, even if limited, they may have had unique ways of perceiving their environment that we have long forgotten. One of the more mind-bending aspects of studying Earth's magnetic imprint is quantum theories that hint at how particles might share information instantaneously over great distances, known as quantum entanglement. While highly conceptual and a world away from practical application, such theories could eventually inspire new ways of thinking about how information is stored and communicated across time and space. The burning question that persists is whether we could ever decipher such complex messages if they indeed exist. What kind of information would make it through the ravages of time, encoded in the fabric of Earth's magnetic fields? And while it's a tantalizing possibility, scientists remain cautious, carefully separating rigorous study from the allure of speculation. Yet history reminds us of times when great discoveries began as mere curiosities. The reality of genetic code, once invisible, is now foundational knowledge in biology. The understanding of sound as waves now seems intuitive, but was once a great leap. Science is a journey made of such steps, where questions once thought fantastical gradually become an inextricable part of our reality. So, we find ourselves at the beginning of a truly fascinating journey. With each new study, with each rock turned over and examined, we inch closer to understanding the magnetic tapestries of our planet. And as we do, we open endless vistas of knowledge about the nature of history, memory, and existence itself. Could the Earth's magnetic field be a keeper of stories long forgotten? While the answer remains elusive, the pursuit is rich and promising, lifting the veil slightly on the vast, magnetic mysteries of our living planet. Chapter 4. Magnetized Echoes. Imagine standing on the edge of the ancient world, a land where civilizations rose and fell, leaving behind stories that we sometimes uncover through stone tablets and remnants of old structures. But what if there is another medium, unseen and unexpected, that holds the deep whispers of our ancestors' Earth's magnetic field? The Earth's magnetic field is a fascinating phenomenon. It stretches out invisibly from the iron heart of our planet, reaching the atmosphere and protecting us from the solar winds. To understand it, picture the planet as a giant magnet, with lines of magnetic force looping up into the northern hemisphere and down in the southern. This vast magnetic shield is vital. It redirects charged particles from the sun that would otherwise strip away our atmosphere, leaving our world barren like Mars. In recent years, scientists have wondered if this magnetic field does more than just protect and guide us. Could it remember? Here's where the idea becomes truly captivating. Remember how cassette tapes and hard drives store information using magnetic patterns? Some researchers are exploring whether something similar could happen in a natural way with Earth's magnetic field. Artifacts like clay, pots, and bricks, when fired, get imprinted with the Earth's magnetic signature of that exact moment. This snapshot is locked in as the materials cool and harden, essentially capturing the direction and strength of the magnetic field as it existed years, decades, or even eons ago. This process, known as archaeomagnetism, allows scientists to build timelines by piecing together these ancient magnetic snapshots, serving as a key to unlocking parts of our history. How might the Earth's magnetic field hold onto memories of entire civilizations? Some propose that changes in magnetic intensity and direction, recorded over millennia, correspond with atmospheric and environmental changes like records in stone left behind for us to decode. It's like having a journal written in a language we're just beginning to translate. Exploring this idea further, consider the odd occurrences of magnetic anomalies across the globe. These are spots where the magnetic field markedly deviates from the norm. Could some of these anomalies be whispers of powerful events, like volcanic eruptions or meteorite impacts, that left their mark on this magnetic memory? Even grand human endeavors, such as the construction of great cities or massive fortresses, possibly generated magnetic imprints due to the sheer amount of iron used and the collective movement of materials. Some remarkable discoveries support these tantalizing possibilities. For instance, studies of ancient clay items found in Syria have given us magnetic readings that detail shifts in the magnetic field concurrent with the vibrant civilizations of the Bronze Age. Similarly, the volcanic rocks around the Hawaiian Islands point to dramatic shifts in magnetic intensity, providing vital clues to ancient volcanic activity. Now, let's take a step back and think about the implications. If we consider the Earth's magnetic field as an enormous natural data bank, then every shift and change holds a piece of Earth's long history. This idea not only enriches our understanding of the planet's past, but also helps predict future changes, a vital tool in our ongoing dialogue with nature. However, the work is just beginning. Specialists in fields like geomagnetism, archaeology, and climatology are collaborating to develop better models and methods to understand this vast magnetic archive. Advances in technology, such as sensitive magnetometers and space-based observatories, are helping unlock secrets long kept by our planet. As we peer into these vast magnetic echoes, we are reminded of how deeply connected we are to our environment and history. This exploration doesn't just bridge the gap between past and present. It expands the possibilities for what we can discover about civilizations that once thrived on this shared Earth. Every investigation into this magnetic archive invites new questions. How did these shifts affect human activities in those distant times? Could changes in the magnetic field have influenced climate and, in turn, the rise or fall of these ancient peoples? By continuing this insightful journey into the magnetic realms of Earth, we are not only uncovering the historical fingerprints left in stone and clay, we are also solidifying our role as stewards of the information, ensuring that we revisit, understand, and preserve these echoes as we walk forward into the future. Chapter 5: Ancient Imprints. Imagine a world where the invisible forces around us hold not only our planet together, but also the stories of those who came before us. Our Earth's magnetic field is one of those invisible forces. It's like a blanket that wraps around our planet, protecting us from the sun's harmful rays and cosmic radiation. But what if, in addition to these well-known roles, this magnetic field carries imprints or memories of ancient civilizations? The concept of Earth's magnetic field holding information is not entirely new. Scientists have long studied the magnetic properties of Earth's rocks and soil through a field of research known as paleomagnetism. This study looks at how rocks lock in the Earth's magnetic field at the time of their formation. By examining these rocks, researchers can learn about the history of Earth's magnetic field, including pole reversals and other changes over millions of years. Yet, the idea that this field might also hold a record of human history is something we're only just beginning to explore. One of the fascinating aspects of our planet's magnetic field is how it changes over time. The field is generated by the movement of molten iron in the Earth's outer core, creating what scientists call the geodynamo. This dynamo process leads to changes in the magnetic field's strength and direction over time. These changes are sometimes recorded in natural materials like volcanic rocks and ocean sediments, which can help us map shifts in the magnetic field and even pinpoint when they occurred. Recent advances in technology have allowed scientists to look more closely at these magnetic records. Using techniques like magnetotellurics, researchers can examine how different layers of the Earth conduct electricity, which is related to the magnetic field. This helps create a detailed map of the Earth's magnetic history. Such maps can act like a time machine, giving us glimpses into the past. One particularly intriguing line of inquiry is how changes in the magnetic field might have impacted ancient human societies. There is evidence to suggest that fluctuations in the Earth's magnetic field could have influenced climate patterns in the past, which in turn affected the development of civilizations. For example, significant changes in the Earth's magnetic field strength have been linked with climate shifts that could have influenced agricultural productivity, migration patterns, and, consequently, the rise and fall of early societies. Moreover, certain archaeological studies have found that ancient civilizations might have had knowledge of magnetism long before it was documented by modern science. The ancient Greeks, Chinese, and other cultures were aware of the magnetic properties of lodestones, naturally magnetized pieces of mineral magnetite. These stones may have been used for navigational purposes, or even as objects of spiritual or cultural significance. The idea becomes even more compelling when we consider geomagnetic anomalous regions, where the Earth's magnetic field is significantly stronger or weaker than the surrounding area. Some of these anomalies, like the South Atlantic anomaly, are still a mystery to scientists. It's an exciting thought that these features might coincide with areas of significant human activity in history, or even suggest locations where ancient peoples might have been particularly knowledgeable about or sensitive to magnetic phenomena. Human curiosity has always driven us to explore the unknown, to find connections between the natural world and our lives. As we continue to study the Earth's magnetic field, we are left with many questions. Could the magnetic field influence have played a more active role in shaping the course of human history? Are the imprints within its grasp simply the result of natural processes? Or might they also be a record of human influence etched into the very fabric of the Earth? Scientists are just beginning to explore these notions, using sophisticated instruments to measure the tiniest magnetic signals and the latest computer models to predict how our magnetic field might behave in the future. As technology advances, we may be on the verge of uncovering a hidden history locked within the Earth itself, a history that, until now, has been obscured by the deep mystery of magnetic secrets. In this journey of discovery, we're not only learning about the planet we call home, we're also gaining insights into ourselves, our ancient relatives, and the incredible story that we are a part of. The Earth's magnetic field is more than a protective barrier. It's a dynamic and potentially revealing archive waiting to be read, offering clues to the rich tapestry of life that has played out on its surface. The quest to understand our world and its past is a testament to human curiosity and ingenuity. Whether or not our planet's magnetic field holds the memories of past civilizations, it inspires us to look deeper, question further, and appreciate the profound connections between the Earth and its inhabitants. Who knows what stories remain hidden, written in the magnetic lines that swirl invisibly around us, patiently waiting for us to notice them. Chapter 6: Pole Shifts and Myths. Imagine looking up at the stars in the night sky and wondering if they've always been in the same place. Now, take that curiosity and bring it back down to Earth, to something our planet does every so often without us even noticing: magnetic pole shifts. It sounds like something from a science fiction book, but it's a real thing that's been happening for millions of years. When we talk about the Earth's magnetic field, we're looking at an invisible force field, almost like a protective bubble, that helps keep us safe from harmful particles from the sun. It has two main points called the magnetic poles, and our compasses like to point to them, thinking they've got the directions just right. But what if I told you that these poles haven't always stayed in the same spot? Sometimes they even switch places. This isn't as quick as flipping a light switch. It's more like a slow dance that happens over hundreds or even thousands of years. This is what scientists call a magnetic pole reversal. Now, here's where things get really interesting. Studies of deep ocean floors and ancient lava flows have shown us that the Earth has gone through these pole reversals many times. The rocks in these areas have tiny magnetic minerals that line up with the Earth's magnetic field at the time they were formed, capturing a historical record. This is like a time capsule that tells us when and where the poles were on the move. It's hard to say exactly when the next switch might happen, But some theorists suggest that shifts have occurred every few 100,000 years, with the last full reversal, called the Brunsma-Tuyama reversal, happening about 780,000 years ago. As fascinating as it is, a magnetic pole reversal isn't something to be afraid of. Scientists say that these shifts don't wipe out life on Earth or cause massive disasters, despite what some tales might have us think. It might, however, create some challenges for our technology, since much of it relies on the magnetic field to navigate correctly. But as far as the evidence goes, life on Earth has thrived, both with magnetic pole stabilities and during their grand reversals. But why do poles shift at all? The Earth's core is like a giant, swirling ball of liquid iron, which creates the magnetic field through a process known as the dynamo effect. This liquid is always on the move, and small changes in its motion can ripple out, affecting the magnetic field and sometimes leading to a shift or reversal. Imagine a lava lamp with its swirling patterns. The bubble inside moves, and the outer appearance changes. Earth's core isn't all that different, though much bigger and a bit less soothing to look at. What puzzles scientists even more is how quickly or slowly these reversals can occur and what kicks them off in the first place. There are a few theories, one being that it's just part of the natural rhythm of our planet. Others think that cosmic events, like asteroid impacts, or even changes in how our planet tilts on its axis, could influence these flips. But so far, much remains a mystery. Let's plunge deeper into the old stories and myths. Ancient civilizations have always had skyward and earthly icons that guided them, some tied directly to magnetic stones and peculiar rock formations. The ancient Chinese were among the first to discover lodestone's magnetic properties, using it to create early compasses long before the magnetic field's complexities were understood. Interestingly, Robert E. Peary, an explorer from the early 20th century, believed he had reached the North Pole, and he used the best compass technology of his time. Did he know then how grand and shifting his target really was? These shifts in our understanding, mirrored by Earth's natural transitions, illustrate that human history and natural history travel hand in hand, each step forward marked by discovery and adaptation. Some believe that abrupt changes in the sun's activity might also influence our magnetic field. Scientific research has shown that solar storms interact with our magnetosphere, sometimes causing temporary changes. It's a cosmic dance where our shield bends but doesn't break. While a strong leap of imagination aligns magnetic shifts with the rise and fall of civilizations, there's no solid scientific evidence to support this grandiose idea. Yet, this thought pushes us to appreciate our planet's history and our part in it. We find comfort in the patterns of heaven and earth, drawing maps of understanding that connect stories from ancient and modern times. Could it be that legend and science are telling the same story but in different tongues? So, when we look at our modern world with technology so dependent on predictable navigation, what would happen if the poles decided to switch again? How would we adapt? As science continues its quest for understanding, it leaves us with more questions and a desire to embrace the unknown. The mysteries of Earth's magnetic changes remind us that much of our world is still unexplored. We keep asking questions, piecing together bits of history, nature, and technology to understand the dance of time, the circle of growth, and the perpetual journey of not just a planet, but of all who call it home. Chapter 7. Hidden Frequencies. In our vast and endlessly fascinating world, there is so much that we have yet to fully understand. One of these mysterious enigmas is our planet's magnetic field. Picture it like an invisible cloak that wraps around Earth, dancing and shifting in ways that are both captivating and crucial for life as we know it. This magnetic field is generated by the movement of molten iron in Earth's outer core. It extends out into space and interacts with solar winds, creating an invisible force that affects everything from navigation systems to the migration patterns of birds. Let's take a moment to explore how this magnetic field has played an unassuming yet pivotal role in human history. The Chinese were among the first to recognize its significance with the invention of the compass as early as the 11th century. This cunning device allowed sailors to find their way across vast oceans. It functioned by aligning itself with Earth's magnetic field and became an indispensable tool for explorers. Imagine the courage it must have taken to sail beyond the horizon, relying only on a small needle's alignment to the Earth's magnetic forces. Modern science continues to delve into other areas of this field, particularly a phenomenon known as geomagnetic reversal. This is when the north and south magnetic poles flip, which has happened multiple times throughout Earth's history. The last major reversal was around 780,000 years ago, and scientists are still trying to comprehend how such reversals unfold and what these might mean for our future. This brings us to an intriguing pursuit, where researchers continue to investigate if there might be more to Earth's magnetic field than we've currently grasped. Certainly, it's a protective shield, a guiding hand, and a dynamic force in our planetary environment. However, could it also, in some complex and previously overlooked way, retain a kind of memory? Intriguingly, scientists collect samples of sediments, volcanic rocks, and ocean sediments which have locked in the direction and intensity of Earth's magnetic field at the time of their formation. These are akin to magnetic tapes that hold pieces of Earth's history. As these materials form, tiny particles align themselves with the magnetic field, acting as historical records of the field's orientation over time. These records have provided clues about how continents shifted, oceans opened, and how complex life evolved over millions of years. It's almost as if they hold secrets, just waiting for us to read them right. As we piece together the story recorded by these natural tapes, we start understanding better the forces that have shaped our environment. Besides geological formations, there is increasing interest in understanding how living creatures, including humans, might have interacted with this magnetic field over time. Many animals, from sea turtles to monarch butterflies and even some bacteria, use Earth's magnetic field lines to orient themselves or navigate vast distances. This is all based on behavioral experiments and biophysical studies that have revealed mechanisms like magnetoreception, a biological ability to detect magnetic fields, chemicals in animals' bodies, or iron-rich structures like magnetite are believed to play a part. Yet this field of study is still brimming with questions. Researchers are equally curious about how unseen energies might have consequences for human technology and health. Wi-Fi, radio broadcasts, and even medical technology like MRI machines rely on portions of the electromagnetic spectrum. There is ongoing research to determine how natural magnetic fields might influence modern electronic circuits, or if prolonged exposure has any subtle effects on human health. Now, let's entertain another thread of this tapestry, something that lies on the border of the speculative yet backed with plausible hypotheses. Some have posited that ancient civilizations might have had knowledge now lost about utilizing Earth's naturally occurring magnetic forces. This leads to questions about the placement of megalithic structures or legends surrounding certain archaeological sites known for strange magnetic abnormalities. Consider Stonehenge or the Great Pyramids. While there's little concrete evidence to connect them directly to Earth's magnetic qualities, these locations have an undeniable aura of mystery and precision in construction that continues to captivate researchers. Their exact relationship with Earth's magnetic properties is not understood, but they do spark a tantalizing curiosity about what ancient peoples might have known or sensed about their environment, whether through art, culture, or technological achievements. While the idea that Earth's magnetic field holds echoes of ancient secrets or unexplored capabilities may, for now, reside comfortably in the realm of speculation, what is undeniable is the magnetic field's enduring impact. It is a magnificent testament to the complex interplay of forces on our planet, continually challenging us to expand our understanding and reconnect with the natural world in unexpected ways. What we stand to learn as we continue unlocking these secrets offers not only insight into the history of our own planet, but also the potential for technological innovations that draw inspiration from the whispering forces that have guided life for countless centuries. It reminds us to look beyond what we see and dive deeper into the unseen, tapping into the boundless curiosity that drives human nature to explore and understand the wonders of the world that surrounds us. Chapter 8. Tracing Magnetonic Clues. Imagine for a moment that our planet, Earth, is not just a rocky sphere spinning around in space, but a storyteller of sorts, holding ancient secrets deep within its core. What if the Earth's magnetic field, the invisible force that guides our compasses and shields us from harmful solar radiation, has recorded the rise and fall of civilizations long past? This idea might make you raise an eyebrow, but it's not as far-fetched as it sounds. Today, we're on a journey to explore how the magnetic field could hold clues to our planet's hidden history, and what scientists are doing to unlock these potential secrets. At the heart of our exploration lies paleomagnetism, a fascinating branch of science that studies the history of Earth's magnetic field. The Earth's core, composed largely of iron and nickel, creates a magnetic field through the movement of these molten metals. This field extends out into space and, importantly, it is dynamic. Over the millennia, it has flipped, weakened, and shifted in ways that can be recorded by rocks. When volcanic lava cools and solidifies, or when sedimentary rocks form, they align their magnetic minerals with the current magnetic field, essentially freezing a record of the field at that time within the rock. One of the most captivating discoveries of modern paleomagnetism is the evidence of geomagnetic reversals, where the magnetic north and south poles switch places. These flips don't happen overnight. Instead, they can take thousands of years to complete and have occurred numerous times throughout Earth's history. Each flip is a chapter in Earth's magnetic storybook. By studying the rate of these flips and their impacts on Earth, scientists have started to piece together bits of the planet's deep past. In our quest to uncover lost tales of humanity, scientists often turn to archaeomagnetism, a subdiscipline of paleomagnetism. Archaeomagnetism uses the same principles but focuses on human-made materials like pottery and bricks. When ancient peoples fired their clay pots or built their kilns, they unwittingly captured the direction and intensity of the Earth's magnetic field at that time. By studying these items, researchers can learn more about the ancient people who made them. For example, by mapping the changes in the magnetic field recorded in several artifacts, scientists can pinpoint the age of archaeological sites where no carbon dating options exist. This magnetic dating technique has been a breakthrough in uncovering timelines of past human activity. A fascinating example of this can be found in the study of ancient Roman pottery. Researchers discovered that some Roman ceramics had magnetic patterns that matched certain sequences of geomagnetic field changes known to have occurred around 500 AD. This suggests the Romans might have been mass-producing these pots during a time of significant magnetic activity. potentially linked with volcanic events or environmental changes. But what if the magnetic field holds even greater secrets about past civilizations? Consider the lore and legends from cultures around the world that speak of ancient peoples with knowledge and technologies far beyond their time. Each continent has stories of civilizations lost to time, such as Atlantis, Lemuria, or the legendary city of El Dorado. While no solid evidence has been found for these places, is it possible that shifts in the Earth's magnetic field could correlate with the sudden disappearance or transformation of these cultures? This is where the investigation becomes truly intriguing. One tantalizing study emerged from the Sahara Desert, where researchers have examined ancient lake sediments to learn about Earth's past magnetic fluctuations. They discovered that around 5,900 years ago, a major climate change event, likely spurred by shifts in the magnetic field, transformed the lush, green Sahara into the desert we know today. Interestingly, this time frame aligns with significant changes in human settlement patterns across North Africa. It's fascinating to think about how these environmental upheavals, possibly related to magnetic changes, might have influenced human development and movement. Moreover, the possibility that ancient architects understood and utilized the Earth's magnetic field is another area of interest. Across the globe, ancient structures like the pyramids of Giza, Stonehenge, and the Nazca lines show precise alignments with celestial bodies and, possibly, Earth's magnetic poles. Some researchers suggest that ancient builders might have deliberately considered magnetic north in their architectural designs, whether for spiritual reasons, navigation, or harnessing Earth's magnetism in ways we are only beginning to understand. The study of this magnetic record is not without challenges. Understanding the full complexity of historical magnetic field changes requires interdisciplinary collaboration, cutting-edge technology, and a bit of creativity. With advanced tools like SQUID magnetometers and synchrotrons, scientists can detect even the faintest traces of past magnetic fields in rocks and artifacts. Imagine the excitement when a new pattern is uncovered, potentially offering a fresh glimpse into the chapters of human history written in the magnetic script of stones. As we peel back these layers, the possibilities of what the Earth's magnetic history could reveal are immense. By mapping changes in magnetism alongside climate records, archaeological findings, and historical timelines, the picture of our past could become more vivid than ever before. It's a reminder that the Earth is a living archive, storing a wealth of knowledge, waiting for us to explore and understand. In this journey of exploration, one is left with wonder and curiosity. How much do we have yet to learn from clues hidden in plain sight? Could the magnetic field one day reveal forgotten lessons from the past that might guide our future? The quest continues, and as we push the boundaries of discovery, we remain the curious explorers, eager to unearth such secrets held within the whispering field of our planet. We are merely at the beginning of understanding the true potential of tracing these magnetonic clues. Chapter 9: Geomagnetic Chronicles. Imagine for a moment that beneath every step you take lies an invisible force, quietly at work, shaping the very fabric of our planet. This force is the Earth's magnetic field. It's like a giant, unseen shield that wraps around the Earth, protecting us from all sorts of cosmic radiation and solar winds that could otherwise strip away our atmosphere. But beyond its role as a protector, what if it holds more secrets than we ever imagined? For centuries, people have been fascinated by the concept of magnetism. Ancient Chinese and Greek philosophers noted its effects without truly understanding the forces at work. Fast forward to today. Scientists have developed sophisticated technology that allows us to study the Earth's magnetic field in incredible detail. This has led to some intriguing discoveries. Curiously, historical records seem to hint that shifts in the Earth's magnetic field coincided with significant events in human history. Could there be a connection? Let's start by understanding how the Earth's magnetic field is generated. Deep within the Earth, there is a dynamic process at play. The core of our planet is made up of molten iron and nickel. As the Earth spins on its axis, the liquid metals move and create electric currents. These currents generate magnetic fields. It's a complex dance of physics and geology that results in the magnetic field we experience. The phenomenon of geomagnetic reversals adds another layer of intrigue. Over hundreds of thousands of years, the magnetic field doesn't stay the same. It weakens, strengthens, and even flips. Yes, that's right, north becomes south, and south becomes north. The last major reversal happened about 780,000 years ago during the Brunswick-Matuyama reversal. Scientists use paleomagnetism to study magnetic minerals in ancient rocks, which store records of these magnetic shifts. These rock records act like time capsules of the Earth's magnetic past. Interestingly, certain civilizations seem to have flourished or collapsed during periods of geomagnetic changes. Historians still debate what happened to the ancient Indus Valley civilization, one of the world's earliest urban cultures, which mysteriously vanished around 1900 BC simultaneously. A sharp decline in the Earth's magnetic strength was recorded in that region. While it's not definitive that these geomagnetic changes directly influenced or contributed to the rise or fall of societies, it does prompt us to ask deeper questions. In recent years, archaeomagnetic studies analyzing the magnetic properties of archaeological materials have offered fresh insights. For example, scientists have found that the ancient pots and bricks used by civilizations can retain magnetic imprints. When these objects were first heated thousands of years ago, their minerals aligned with the Earth's prevailing magnetic field. By studying these relics, researchers gather data on past geomagnetic conditions, filling in little pieces of our planet's magnetic puzzle. Another captivating consideration is the South Atlantic Anomaly (SAB), an area where the Earth's magnetic field is particularly weak, stretching from South America to Western Africa. It's a bit like a cosmic pothole that lets more radiation reach closer to the Earth's surface than usual. Satellites passing over the SAA often experience malfunctions, and scientists keep a close watch on this uncommon region. The anomaly's origins and implications remain points of scientific study, opening doors to better understand the complexities of our magnetic field. Looking to the future, researchers employ various models and simulations to predict how the magnetic field might behave. Will it flip again soon, or stabilize? There's much debate. Some projections see field weakening happening faster than before, while others argue such shifts might be mere quirks rather than major trends. Satellites such as the European Space Agency's Swarm mission play an essential role by providing continuous measurements of the magnetic field's changes and offering more clues to its ongoing evolution. As we ponder these discoveries and hypotheses, questions spill forth. Could magnetic changes affect human health or behavior in subtle ways we've yet to understand? Are there unexplored connections between geomagnetic shifts and long-term climate patterns? How might changes in our magnetic shield influence technology and modern life, given our dependency on satellite communications and navigation systems? While the idea that the Earth's magnetic field may be aligned with human history is intriguing, it's critical to stay grounded in science. Enthralling as the concept is, drawing direct lines between geomagnetic conditions and societal developments requires rigorous evidence. However, the interconnected nature of the Earth prompts a sense of wonder, curiosity to explore what remains hidden within these unseen forces of nature that protect and shape our world. As we continue our journey of discovery, remember that science is not just about answers, but also about asking the right questions. The mysteries of the Earth's magnetic field invite us to explore intersections of geology, archaeology, and history, enriching our understanding of how interconnected our planet's processes truly are. While we may not yet have the full story, each study, each finding nudges us a little closer, compelling us to unravel the rich tapestry woven by Earth and time. Chapter 10. Civilization's Signature. Imagine uncovering a diary that holds secrets from the past. What if our planet had such a diary, and it wasn't written on paper or in stone, but instead hidden in the earthly forces that surround us every day? Let's embark on a journey to understand how the Earth's magnetic field might hold echoes of ancient civilizations, and perhaps more than we ever dreamed. The Earth's magnetic field is an invisible force surrounding our planet, generated deep within its core. It's like a giant magnetic bubble that protects us from the harmful radiation from space and helps guide everything from birds flying south to humans navigating their world through compasses. This force has been a part of the Earth long before humans ever set foot on it. But what if it has also been recording the rise and fall of civilizations around the globe, weaving a tapestry of humanity's greatest stories into its fabric? To understand how this might be possible, we need to dive into how our planet's magnetic field operates. The magnetic field is produced by the movement of molten iron and other metals in the Earth's outer core. This movement creates electric currents which, in turn, produce magnetic fields. As time passes, these fields change and shift, much like the ebb and flow of the tide. They're constantly moving, changing direction, and even flipping completely, where the magnetic north and south poles switch places, a phenomenon that has happened multiple times throughout Earth's history. Now, scientists have discovered that this field can get imprinted on rocks and archaeological materials. This process, known as paleomagnetism, allows us to catch glimpses of the past. When volcanic rocks cool and harden, or when sediment solidifies, the iron particles within them align with the Earth's magnetic field at that time, effectively freezing that moment in history for us to discover later. It's as if the rocks become time capsules, safeguarding a piece of the planet's magnetic signature from millions of years ago. But what does all this have to do with the stories of past human societies? Well, researchers have found that not only geological materials, but also ancient human artifacts, like pottery, can capture magnetic information. As ancient peoples fired their clay pottery, the intense heat would reset the magnetic minerals within. As the pottery cooled, these minerals would align with the Earth's magnetic field at that moment. Each pot, each fragment, is like a tiny magnetic recording, capturing not just the local magnetic field, but hints of the environment and even the broader world of the time. Remarkably, by studying these magnetic records, scientists have been able to piece together parts of human history. For instance, they've used paleomagnetic data to date archaeological sites with incredible accuracy, offering new insights into when and how ancient people lived. This has helped refine timelines of human activity and cultural development in ways that few could have imagined before. It's like having an unfinished map that's slowly filling in with each new find, telling us more about our ancestors with every dig and discovery. But here's where things get even more fascinating. There are theories suggesting that the advancement of certain ancient civilizations might have been influenced by the magnetic field's changes. Consider some of the magnetic field reversals or significant shifts these could have impacted not only the environment, but also the way early humans perceived the world around them. Could these shifts have inspired religious beliefs, navigational strategies, or societal changes? Such considerations invite us to imagine that perhaps the invisible lines of the magnetic field have, indeed, in subtle ways, been guiding the course of human civilization. Scientists and researchers are still exploring these possibilities, seeking firm evidence to understand fully the relationship between the Earth's magnetic phenomena and human history. While we know that the magnetic field holds clues about the geological past, there's much more to uncover about its potential role in the story of human beings on this planet. While we unravel these mysteries, we are reminded of just how interconnected we are with the forces of nature. Our curiosity leads us to look at the world with fresh eyes, to wonder not just about the civilizations we know of, but also about the many more that remain mysteries waiting to be unveiled. With every step forward in understanding the Earth's magnetic field, we venture a step deeper into our own origins, pondering the untold connections between us and the universe. In this way, we realize that beneath the surface where science meets wonder, there is still much to learn. And perhaps one day, as we continue to unravel the magnetic diary of our planet, we will uncover even more stories of our past. Stories waiting patiently in the stones and soils to be read by those curious enough to seek them.